as Brian alluded to, this is a project to have a more focused effort on downscaling global climate models to regional scales that are more relevant for ecosystem and fisheries management. So here in Hawaii, we're well aware of the goods and services and the value that the marine ecosystem provides to society. And we're trying to get a better understanding of how changes in climate and oceanographic processes influence those services. So really, we'd like to focus on developing more climate resilient communities and improve human well-being when faced with climate change. And so some of the major climate processes that we're thinking about here are changes in productivity, temperature, ocean acidification, changes in oxygen, many of the processes that Brian talked about earlier. An issue, though, is that many of the climate and ocean simulations that we use to understand these forces are driven at the large scale and poorly resolve the coastal scales that are valuable to communities. So we have this mismatch here between what the climate models simulate and what the information that we would need to drive models that can simulate ecosystem processes and improve social outcomes. Brian also did an excellent job about talking about the global climate models and really their inability to simulate processes at the coastal scale. So if you look at this postage stamp diagram of various ecosystem conditions that are necessary to simulate coastal ecosystems, you can see that Hawaii is not represented in these models, maybe 1 point, as Brian mentioned. Another depiction of this is just looking at the ocean chlorophyll as estimated from satellites. We can see the Hawaiian Islands there, but when you look at one of these global climate models, completely flat, right? The Hawaiian Islands are not represented. So there really is a need for more consistent downscaling efforts to translate the global climate signal into processes that influence the coastal community. Not just in Hawaii, but on continental shelves around the world. So NOAA is pursuing this with a new project called the Climate Ecosystems and Fisheries Initiative, or CEFI. And the objective of this new program is to build a nationwide operational ocean modeling and decision support system that can provide information about changing ocean conditions at scales needed for resource management and conservation. And so there's a coordinated effort between OAR, the Office of Ocean and Atmospheric Research, and the National Marine Fisheries Service to downscale the global climate models into the coastal zone with the intent of covering the entire US EEZ. Models around the continental US and the Arctic Ocean have been developed and are running now. And as Brian mentioned, we are developing such a model for the Pacific Islands region. The Pacific Islands region, as we're all well aware, is very large, about 50% of the total US EEZ. And so we're not able to downscale the entire US EEZ in the Pacific initially, but we're starting with the Hawaiian Islands where we have the most data for model data comparison. And then once successful there, with additional resources, we'll move on to our jurisdictions. So we have a initial grid developed and running, and in the future, in the coming fiscal years, this will be forced with global model output that will allow short-term predictions and long-term projections of ocean conditions. So this last fiscal year, we configured the model. In this current fiscal year, through the end of fiscal year 25, we're going to conduct an initial 30-year hindcast of conditions in the region. And then in the next fiscal years, we'll update that hindcast as well as focus on climate projections several decades in the future, as well as short-term seasonal to annual predictions. So here, if we step back to this diagram for a second, we had that gap in between the existing global climate models and the social outcomes, but with regional downscaling, hopefully we can bridge this gap between what we think we recognize as the impacts of climate change at the global scale, with coupled ecosystem models, species distribution models, management strategy evaluations, and then some economics models to work towards the social outcomes and resiliency that we'd like to see in response to the threats from climate change. I made a note here at the top that although the scientific capacity is increasing, I feel like a gap that we have in this strategy is the science policy interface. So we have physical oceanography and climate science, we have ecosystem science and social science. I feel like there's a gap here in translating that science into policy decisions. And so I just put this in here to remind myself to mention that we have some new funding that is going to support somebody at about the postdoc level working at that interface between science, climate science, and fisheries policy in the Western and Central Pacific region. So if folks know anybody, a recent graduate or somebody who's going to graduate soon, interested in working at that interface between science and policy, please let me know because we're going to be looking to bring somebody on fairly soon. All right, people involved in the CEFI project, or this Climate Ecosystems and Fisheries Initiative at the Pacific Islands Fisheries Science Center, are listed here. And I wanted to touch on a few of the initial projects that are being pursued as part of this initiative. The first here is the downscaling that Brian mentioned. Dax Matthews has a poster in the back to talk about developing this regional model for the Hawaiian Island chain that's going to include physics and biogeochemistry. So the biogeochemical model that is included here is called COBALT. COBALT stands for carbon and ocean biogeochemistry and lower trophic levels, or something like that. So it includes the carbonate system, nutrient and oxygen cycles, and then lower trophic levels being 3 classes of phytoplankton and 3 classes of zooplankton. Models like this are going to feed ecosystem models. The model mentioned here is called Ecotran. Ecotran is a model that is developed by Jim Ruzicka at the Science Center, and it is really meant to simulate the trophic interactions between different groups in the pelagic ecosystem. What's different about this configuration of Ecotran in comparison to what Jim has worked on in the past is that he's really focusing on the vertical resolution of the ecosystem so that he can simulate the sensitivity of changing oxygen and temperature conditions, or the sensitivity of vertical migration to changing oxygen and temperature conditions. Jim is also working on a more regional implementation of Ecotran as well, just focusing on the archipelago. Another project here is something led by Justin Suka. I think that I understand why he left CIMAR to join UH, but it is definitely a loss for us. Justin is going to be continuing to collaborate with us in simulating species distribution models and simulating species distributions using models that rely on data from the Hawaii longline fishery in the Observer program. So it's, this modeling approach is able to isolate the roles of changes in gear and oceanography across the fishery and then identify the environmental drivers that should really be considered as we look at changes in climate in the future. Coupled with this effort is another parallel effort led by folks in NOAA to better use satellite data for fisheries management. And so while the CEFI project, or this climate change focused project, is going to focus on long-term projections or short-term predictions and long-term projections, there's a satellite oceanography based project that will be simulating species distributions in near real time. Moving a little higher up the food chain, Hingling Chan at the Science Center is going to be developing models that can simulate the impacts of climate variability and change on the economics of the longline fishery, both on trip cost, trip distance, fish price, and location choice. So data that is coming out of the regional model that DAX is developing can be fed into the ecosystem model that Jim and Justin are working on, and then those data can be fed into this economics model that Hingling is pursuing. And then finally, it's important to note that what we think about when we think about fisheries oftentimes relates back to economics and kind of the economic well-being of the commercial fishery, but that is not what's important to a lot of society. So maybe it's the most important economically, but there's a lot of social consequences of climate change that are maybe outside of the commercial fishery. And Kirsten Leong is leading an effort to develop biocultural indicators and thresholds that can be used to monitor the impacts of climate change and then better target our ecosystem models and the types of indicators that are developed from those ecosystem models. So the decision support team at PIFSC will be working to build a framework that will meet some of the core climate-related needs, including estimates of ocean physical state, biogeochemical conditions, changes in species distribution and production, the economic consequences, and the social outcomes to changes in future climate. And this is going to be targeting past climate variability, the present day, and future conditions. Data from this project, or the initial parts of this project, will be shared through a NOAA data portal hosted at the Physical Science Laboratory in Boulder. So data is intended to be shared with the community once it's being produced. We hope that this framework can support an array of collaborations and meet a lot of science needs at UH and other institutions. So we really hope that folks reach out to us for collaborations as this moves forward. Great, thank you.